I absolutely love my new Bamboo X1 Carbon. It's an amazing 3D printer for someone like me who just wants to turn on my 3D printer and print things reliably, fast. But I can't for the life of me figure out how Bamboo managed to come out of nowhere, build an amazing 3D printer on their very first attempt, but somehow they managed to overlook how terrible the included light is. I mean, look at this thing. It can barely light up the inside of the chamber, especially when looking through the front tinted glass, and it even makes the camera live feed difficult to actually see what's going on and detect any print errors, especially when printing in black filament. A quick search of Reddit revealed many other users unhappy with the built-in light on their X1 Carbon too, so it wasn't just me. I knew I had to fix this lack of light somehow, and of course slip some smart home functionality in there at the same time. I first headed over to my go-to place for something like this, which is of course printables, to see what other members of the community had come up with. A quick search revealed a couple of great options, which essentially raises up the top glass panel on a riser to allow an LED strip to be placed underneath to light up the entire chamber from the top down. There were some really creative designs like this DK riser, which features vents with magnets and an included shield, but I wanted something a bit lower profile and stealthier, which luckily the same creator already had designed. This one consists of 8 main parts, 4 corners that clip together with a separate TPU piece that sits on top to hide the glare from the LED strip coming through the glass when looking down through the top. I set about printing all of these parts, which would take a couple of hours, so I started researching which LED strip I was going to use. Most of the LED mods I noticed other members of the community running were all standard 5 or 12 volt strips, which they would then run to an external power supply from the wall, meaning it would be one power supply for the printer and another for the LED strip. But I wanted to avoid doing this, if at all possible, for 2 main reasons. Firstly, I'm extremely short on plug space under my desk, but most importantly, the printer itself already has a perfectly good power supply with lots of power, so why wouldn't I just use that? A quick search of Bamboo's documentation revealed that the power supply inside is a 24 volt unit, which is actually great, as that happens to be a common voltage for LED strips. My next criteria were that it had to be a COB strip to reduce any glare and visible LEDs through the glass, and that it had to be addressable RGBW. Realistically, I could have went for a plain white one, but I had a few other ideas in mind of what I wanted to use the RGB for, and I thought, why not just go full send and go complete overkill? After hours of searching, I finally found one that fit the needs from BTF Lighting. It's a 24 volt strip with addressable RGBW and its COB or chip on board, which basically means that rather than individual LEDs that are all visible on a standard strip, the LED chip itself is directly mounted on the PCB, meaning you can get more LEDs per meter, and typically means that they come with this layer of diffusion already built into the strip, which makes it much harder to see the individual LEDs. For context, the highest amount of LEDs per meter you will typically see on a standard strip is around 144, but this COB strip has more than 5 times that at 784 LEDs per meter. This should make for a pretty interesting setup. It is quite expensive for all of the features that I wanted, but COB strips with just white or just RGB or even standard LED strips are a lot cheaper if you would like to keep the costs down. Parts completed, I grabbed them out of the printer and there's a problem. The LED strip that I had chosen was just a bit too big for the channel that's built into the riser, with no real way to make it fit without some modification or damaging the LEDs. Back to the drawing board. Not able to find any designs that could take a 10mm LED strip on printables, I turned to MakerWorld, which revealed this little gem of a design from a Neo Sai. This one also has 8 parts, 4 corners and 4 shields, but it's able to take a much wider LED strip due to there being no channel, but rather the LED strip fixes to the side wall of the riser. Perfect. After removing the AMS from the top, which holds 4 spools of filament and lets the printer change between different materials and colours, even in the middle of a print, I did the one thing that you have to do before starting any project like this: empty my poop chute. Starting with the main section of the frame, which clipped together very easily, I loosely positioned the LED strip inside the frame so that I could figure out where the cut point was going to be. The back of the frame has a nice exit hole that allows the routing of the cables through, with a little gasket printed from TPU to allow pass-through. Luckily, the cut point for the strip ended up perfectly at the end of the frame without any gaps. These COB strips are really quite flexible, however the angle of the corners made sticking them down a little tricky, so instead of cutting and soldering a bunch of times and having a gap, I decided to just stick it down on the flat sections and leave the corners floating. I do have concerns that over time the heat from the strip and the printer might loosen the glue over time, so I'll probably just come back and hot glue it or something else. Unfortunately, the TPU gasket wasn't quite big enough for the wires on my strip, so I left that out for now. This was my first time trying the fitment of the riser on the printer itself, and the fit was pretty good. It does have slightly more wiggle room than I'd like, but realistically it's not something that gets moved often anyways. You can see that the main sections of the riser have these little grooves in them, which allows the anti-glare shield to slot in and cover over the LEDs so that they aren't nearly as visible from the top. I double-sided taped each of the sections of the shield, and it all slotted together really nicely and actually hides the LED strip by quite a lot from the top side. Then, to allow a nice smooth surface for the glass top to sit on and avoid getting scratched up and reduce vibration noise, I picked up some of this 1mm EVA foam as recommended by AneoSci, which is actually the same stuff that you will find under the regular glass top to give the same protection. I started cutting up some 20mm strips for each edge and stuck them down again with some double-sided tape to the top of the riser, and then refitted the glass panel to the top. With the riser and the strip installed, it was time to tackle the wiring and the controller. Now, you get LED strips that have varying levels of control. You get ones that are just simple on and off, you get ones that can dim and cycle between different colors with a remote, but because this is a fully addressable setup and I wanted to integrate this into my smart home, we are going to need a controller that can handle that. The nice thing about an addressable strip like this is that you actually only need 3 wires: power, ground and data, which controls all of the LEDs on the strip via some sort of controller. And I already had the perfect controller in mind for this, which is our EST-PoE32, a power over Ethernet board based on the ESP32. Now, before you get all excited thinking that this whole setup is going to run over PoE, unfortunately it can't, as the power requirements would far exceed what PoE can deliver. This board does have another little trick up its sleeve, however, which is that you can also power it via these screw terminals, which accept anywhere from 9 to 28 volts DC. And if you remember earlier, I already discovered that the power supply from the Bamboo provides 24 volts. Hopefully you can see where this is going. The only question was how to get the 24 volts out from the power supply located deep inside of the printer to our ESP32. Once again, looking through the rather excellent Bamboo maintenance guide for the X1, I found the disassembly guide to get to the power supply and quickly realized it would need quite a bit of disassembly to access the power supply inside the machine, with no obvious way to get the cables out of the printer so that I could easily access the controller if I needed to without some sort of drilling or modification. There had to be a simpler way, otherwise I was going to have to resort to running another power supply outside of the machine. After staring the machine out for a few minutes, I had a eureka moment. Remember the AMS that I talked about earlier that allows multicolor printing? Well, the X1 can actually print up to 16 colors and materials all at once by connecting up to 4 AMSs all to a single printer, and this is all done with a single cable that connects back to the printer. That's because each AMS has 2 ports on the back of it for daisy chaining it to another AMS, meaning that all the power is done through this single cable too, which we should quite easily be able to extract. And the only question was, how much power does an AMS draw, and would it be enough to power our LEDs safely? Doing some further digging, I found that Bamboo has been running a beta test for this expansion board, which can be powered via the printer via the 4-pin cable. And looking at the wiki for the expansion board, it says that the max that the whole board can draw is 2 amps in total. So I figured as long as I stay under that 2 amp limit, which is 48 watts, we should be good to go. Conveniently, the specs for these LED strips are listed as 21 watts per meter, and my setup uses 1.3 meters of LEDs, which means that we are running 28 watts in total, which should be well under the max of 48 watts. But to actually get power out of the AMS port, I was going to need a cable. Luckily, Bamboo has a bunch of spare parts on their website, including an AMS cable that I could use to power the board, which I swiftly cut in half in preparation. I then had to figure out which pins on the AMS were the power pins, but I wasn't sure how to do that without accidentally blowing something up. Bamboo manuals to the rescue again, which they tell you exactly which pins are which on the AMS, which is the top left pin for voltage and top middle pin for ground, which I then verified with a meter, and indeed I was getting 24 volts out. Perfect. The individual strands inside of the AMS cable were color coded luckily, which was nice, but appeared to just be a random color, as when I did a continuity test using the input port on the AMS, I found that the red wire was ground and the yellow wire was live. But this could be different in your cable, so please do double check that if you're going to follow along for yourself. It also goes without saying that if you're going to follow along with this, then please do be careful and triple check your work to make sure that you don't cause any damage when doing wiring. I want to take a quick moment to shout out the sponsor of today's video, PCBWay. You will have seen me using our ESP32 PoE dev board as the brains of our LED strip controller for this project. Well, PCBWay is the one responsible for helping turn our designs, ideas and prototypes into the finished product that you can buy. But they aren't just available to companies buying hundreds, thousands or even tens of thousands of devices, but they are open to anyone and can do PCB manufacturing of as little as just 5 boards at an extremely affordable price. So if you want to turn an idea for something that you have that exists on, say, a breadboard into a fully completed and professional PCB, check out PCBWay with the link down below, and thank you PCBWay for helping support fun 3D printer mod projects like this one. Now let's get back to wiring up our controller. Now that we have the wiring figured out, I grabbed a case that I had printed earlier for the EST-PoE32, which is available for free to download and print yourself if you're using this board, and using some command strips, I stuck the base plate of the case to the back of the printer and started screwing in the power wires for both the AMS cable and the LEDs. The EST-PoE32 has 2 screw terminals so that you can both power the board and something else at the same time. Finally, I wired the data pin from the LEDs to a spare GPIO pin on the controller with just a bit of jumper wire. Now we can actually test to see if the whole thing even works. So with the power onto the printer, I plugged in a USB cable to the controller, ready to flash the controller with WLED. If you have watched this channel for a while, you will have seen me use WLED in the past for my kitchen lights, but if you haven't, then WLED is this really cool open source software for ESP32 devices that allows you to work with a bunch of different LED strips to create really powerful lighting effects very easily. It is truly amazing. WLED has a quick install page that lets you install it using just a browser, and it takes under 2 minutes. I have selected the Ethernet version for this board since we do have the option of adding Ethernet to it in the future if we want to, if we don't want to just rely on Wi-Fi. Once installed, I just had to visit the WLED webpage and then tell it which strip I was using, in this case it's a WS2814, tell it which GPIO pin I plugged the data wire into, which was pin 15, and finally I set a power limit up at the top of 1.3 amps, which is just over 30 watts. This means that WLED will limit brightness if it needs to stay under the power consumption, which it shouldn't get to anyways in this case, but it's reassuring just to set it in case. Finally, I can turn on the LED strip and It works! The whole chamber lights up beautifully and it looks so good. I can change the color temperature, the RGB color and brightness, and it's all working great. The only thing you might need to do is change the RGB order so that the colors are displayed correctly. In my case, I had to change it to BRG and also swap the white and the green values. All that was left to do from a hardware point of view was to put the top lid on the case, rewire in the power to the screw terminals and tape up the extra wires coming in from the AMS, resulting in a pretty clean setup, I think personally, since it's all going to be hidden at the back of the printer anyways. After putting everything back in place, my storage drawers and AMS back on the top, it was time to add some automation. Since I'm using Home Assistant, which is the smart home platform that I use for all of my automations, automating the printer is extremely easy with two integrations. Firstly, there's a community-made integration for Bambulab printers made by Greg Hesp, which is amazing and provides loads of extra controls and sensors, including the built-in light, fans, print jobs, the camera, print status, and even the current task in the job it's printing. So I could use all of this information in my automations to control the LED strip. The second integration is WLED, of course, for the LED strip, which if I now go into Home Assistant, it has already been auto-magically discovered as soon as the LED strip controller connected to the network. And this provides controls for the LED strip, including brightness, color temperature, effects, and much more. Using these two integrations, I created myself a couple of automations. The first one is to just turn the LED strip on or off whenever the original built-in light gets turned on or off, and this is just make it look as stock as possible. A question I'm sure some of you have is, doesn't the LED strip mess with the LiDAR of the 3D printer? I'm actually not sure, as I use the texture plate pretty much all of the time, which means no LiDAR, but I added my next automation to it just in case I ever do, which basically turns off the LED strip until after the printer has completed its calibration steps it does in the beginning and has moved on to printing the first layer. You can do this by using the information provided about the current stage, which tells you when it goes from bed heating to auto leveling to printing, and combining that with the current layer, so as soon as it changes from auto leveling to printing layer 1, I can turn the light back on again and should solve any LiDAR issues I may run into in the future. The final automation, and the real reason I actually wanted an RGBW strip, was for showing different colors depending on the status of the printer. Whether a printer had completed successfully, or there was a print failure, or filament had ran out, or color was changing, and various other statuses, since all of these errors and more get reported back to Home Assistant. Funny story, I actually started writing a big automation for this when I realized that I actually didn't know what all of the possible statuses would be, since I haven't even had some of them occur yet. So I didn't know what the entity would show under certain situations. So I headed over to the GitHub repo for the Bamboo Custom integration to see if they were described there, when I realized that Greg had already made a blueprint for this entire situation using a WLED controller, which is awesome. This blueprint can handle all of the different types of situations you might run into and change the LED strip to match or indicate the status. Freaking awesome, and saves me a job trying to figure out all of the different status types. This means that whenever a print job completes successfully, the color changes to green, and if there's a failure, it turns to red, and so on. I really love this mod. Overall, I am so happy with how this mod turned out. It's a huge improvement over the stock light and means that you can actually see what's happening properly on the camera when printing in darker materials, and makes it much easier to identify any issues during a print so that you can decide to remotely stop the print or not. In theory, this should also help with spaghetti detection too, which is where the camera automatically detects a print failure using some sort of ML or AI. Since this is done with the camera and the better picture quality we can give to the camera with more light, that should help and improve detection. For me, this is the light that the X1C should have shipped with by default and improves the experience by a lot. bringing it up on par to match the quality of the rest of the machine. That is it. That's how I fixed the worst problem about my new X1 Carbon. Of course, it's a pretty minor nitpick overall, but when you have a machine that feels really high quality in every other way, it's a shame that they let something like this, so simple, slip through the net. But really glad it's fixed now, and honestly it was a really fun project to tackle. If you fancy giving it a go for yourself, I will of course have everything linked down in the description to where you can buy everything. Let me know your thoughts down in the comments of what you thought about the before and after of this mod, and maybe if you're thinking of doing something like this for yourself. Honestly, this is such a big upgrade for me, and yeah, really happy with it. Thank you so much for watching. Please drop this video a like and get subscribed, and I will see you in the next video.